Hello everyone, welcome to SCI-EASE. In the last video, we discussed about the physical properties of metals and nonmetals. In this video, I will tell you about the chemical properties of metals and nonmetals. Side by side, we will discuss the chemical properties, that is reaction of metals and nonmetals with air, water, acids, and some salt solutions. So first is the reaction of the metals with oxygen. When metals, they are burnt in air, they react with the oxygen present in the air and they will result in the formation of metal oxides. This is a general equation. That is metal plus oxygen from the air result in the formation of metal oxides, and these metal oxides are basic in nature. That is, they turn red litmus solution blue. Basic, so confirmatory test, that is, they turn red litmus blue. Some metal oxides, not most of the metal oxides, but some metal oxides, they are soluble in water and they result in the formation of alkalis. That is, they will result in formation of hydroxides. I will tell you later on. Now, one thing you must know, that vigor of the reaction with water depends upon the chemical reactivity of metals. Some metals, they will react with oxygen at room temperature. Some will react on heating. For some, strong heating is required, and for some, prolonged heating is required. So it depends upon the chemical reactivity of the metals. I will tell you this by taking some examples. First is, sodium and potassium react at room temperature only. Sodium, it will react with O2, Na react with O2, result in the formation of Na2O. And this is the basic oxide. Sodium oxide, that is the basic oxide, it will turn red litmus solution blue. Now, I told you that some oxides, they are soluble in water. So sodium oxide, it is soluble in water. It will react with water and this will result in the formation of sodium hydroxide. In the same way, potassium also. Potassium has a great reactivity with air or oxygen present in the air. The same reaction will take place. You will write this reaction, you will practice it on your own. That is K plus O2. So this will result in the formation of oxide of potassium. Oxide of potassium can also react with water and this will result in the formation of potassium hydroxide. Both these elements, that is sodium and potassium, they are most reactive when they are placed in open air. They will catch fire. So they are kept in kerosene. This question is very, very important. Why sodium or potassium, they are kept in kerosene? Because of their reactivity. Now, come to magnesium. Magnesium burns on heating with air. This reaction we have already done in chemical reaction. When magnesium ribbon is burnt in air, this will result in the formation of white powder which is magnesium oxide. But the reactivity, if we compare the reactivity of sodium, potassium with magnesium, so magnesium is less reactive than sodium and potassium. So it will be placed below this sodium and potassium in the reactivity series. Magnesium oxide is again basic oxide. It can react with water and this will result in the formation of magnesium hydroxide, MgOH whole twice. Now next is, I will take the case of aluminium. Aluminium metal is less reactive than magnesium and it burns in air again on heating. Aluminium, it reacts with O2 and this will result in the formation of aluminium oxide, Al2O3. One very important term I am going to tell you. Here I have not written the basic oxide. It will form, aluminium will form basic as well as the acidic oxide. So those metals which form basic as well as the acidic oxides, they are known as amphoteric oxides. One question that is often asked, give two examples of amphoteric oxide. So it is aluminium oxide and second example, that is zinc oxide. It is again the amphoteric oxide. Amphoteric oxides can react with acid as well as alkalis. So when amphoteric oxide, that is Al2O3, it reacts with acid like HCl. This will result in the formation of AlCl3 plus H2. Okay, so you are to balance it. It is 2, here it is 6, how many? Here it is 3. Equation should be balanced, I have told you. Now it can react with alkali also. So the reaction is Al2O3 plus NaOH. Sodium aluminate plus hydrogen, that will be formed. Okay, sodium aluminate. I will balance the equation first. Here water is formed. So the reaction is Al2O3 plus 2 NaOH forming, this is sodium aluminate. Clear? So amphoteric oxides, they are very, very important. Give two examples or define amphoteric, but you should know, and these reactions are also very important. Next comes iron. Iron is not so much reactive with air. It can react on heating. In the same way, next comes the copper. Copper metal does not burn in the air even on strong heating. Copper reacts with oxygen only on prolonged heating. So the reaction is copper plus oxygen forming copper oxide. Black color of copper oxide, that is formed. So this is the reactivity series. Copper, that is the least reactive. And Gold and silver, they do not react with air. They do not react with oxygen, so they are placed below at the last point of the activity series. This is all about the reaction of the metals with oxygen or air. Now come to the reaction of the non-metals with oxygen. Non-metals, you can name carbon, sulfur, hydrogen. They are non-metals. They react with air to form the acidic oxide or the neutral oxides. I will take the example. Carbon plus oxygen results in the formation of carbon dioxide, which is the acidic oxide. This carbon dioxide, it can dissolve in water and result in the formation of an acid known as carbonic acid. In the same way, sulfur can also react with oxygen of the air and results in the formation of sulfur dioxide, which is again acidic oxide, and this will react with water to form sulfurous acid, that is H2SO3 that is formed. Oxygen, it can react with hydrogen also. And this will result in the formation of water, which is a neutral oxide. So, here is the difference between the metals and non-metals. Metals, when they react with oxygen, they result in the formation of basic oxides. And the non-metals, when they react with oxygen of the air, they result in the formation of acidic oxide. Second chemical property of metals and non-metals, that is reaction of the metals with water, reaction of the non-metals with water. This first is the reaction of metals with water. Water may be cold or hot. When metals react with water, this is a general equation. This will result in the formation of metal hydroxide plus hydrogen gas. In the same way, when metals, they react with steam. Steam is also the form of water vapors. This will result in the formation of metal oxide, not metal hydroxide, metal oxide plus hydrogen gas that will be formed. Now, I will explain these reactions by taking some examples. Take the case of sodium. Sodium reacts violently with cold water. This will result in the formation of sodium hydroxide plus hydrogen gas plus lot of heat that is produced. The reaction is exothermic in nature. Due to this heat, hydrogen will burn and it will catch fire, and small explosions are there. In the same way, potassium, it also has a violent reaction with cold water. Same equation that can be written for potassium. Next is magnesium. It reacts with hot water. Magnesium reacts with hot water and it will result in the formation of magnesium hydroxide plus hydrogen. One thing I want to tell you, that same magnesium can react with steam also. But there, the product, that will not be magnesium hydroxide, it will be magnesium oxide plus hydrogen will be formed. So magnesium can react both with hot water and or steam. Now next is some metals. They can react with steam like aluminium, zinc, iron. I have given this example, reaction of steam with aluminium. This will result in the formation of metal oxide. Aluminium oxide will be formed and hydrogen gas that will be liberated. In the same way, you can give reaction with zinc or iron. Some metals like lead, copper, silver and gold, they do not react with water or steam. So, what metals do? Metals, they displace hydrogen from water and results in the formation of hydrogen gas. Now come to the reaction of non-metals with water. Non-metals do not react with water or steam to evolve hydrogen gas. This is the difference between the metal and non-metal. Why? Because non-metal cannot give electrons to reduce the hydrogen ions of water into hydrogen gas. Third point of difference between metals and non-metals, that is the reaction of the metals with dilute acids. Metals usually displace hydrogen from dilute acids. Some metals like copper, silver, gold, they do not displace hydrogen from acids, so they don't show the reaction of metals with dilute acids. The general equation for this is metal plus dilute acid forming metal salt plus hydrogen. I will tell you this by taking some examples. Sodium. Again, sodium and potassium, they have violent reaction with air, water as well as with acids. And this will result in the formation of sodium chloride and hydrogen gas that will be formed. Magnesium, it can also react with hydrochloric acid to form magnesium chloride plus hydrogen. But the reaction is less violent than sodium and potassium. Now come to the case of aluminium. With aluminium, it will also result in the formation of aluminium chloride plus hydrogen, but in the beginning, the reaction is quite slow. Why? Because of the oxide layer over the aluminium metal. But as the reaction goes on, this oxide layer that will dissolve and then the reaction will take place. With iron, means this is the reactivity. It depends upon the chemical reactivity of the metal. Iron, that will also form iron chloride plus hydrogen, but reaction that is not so violent here. So metals, they are arranged like this in the just like the activity series. But when we take the case of copper plus HCl, there will be no reaction because copper cannot displace hydrogen from acid. In the same way, silver and gold, they do not react with the dilute acids. So, one thing, instead of HCl, we can take dilute sulfuric acid also. When we take dilute sulfuric acid, instead of this chloride, what will be the result? Sodium sulfate when I am taking sulfuric acid here. So here sodium sulfate that will be formed. So in all these cases, when I will take the sulfuric acid instead of HCl, the sulfates of those metals, they will be formed, magnesium sulfate, aluminum sulfate and so on. Now consider the case of nitric acid. When metals, they react with dilute nitric acid, then hydrogen gas is not evolved. Why? Because nitric acid is an oxidizing agent and it will oxidize hydrogen which is formed to water. But nitric acid, dilute nitric acid, it can form nitrates and hydrogen gas with magnesium or manganese. In case of manganese, manganese nitrate will be formed, and in case of magnesium, magnesium nitrate will be formed. Now, one very important thing I want to tell you. Sometimes it's asked, what is aqua regia? Aqua regia is a freshly prepared mixture of 3 parts of concentrated HCl and 1 part of concentrated HNO3. This is a very strong mixture, and in this almost all the metals, they can dissolve. Even gold can dissolve in this aqua regia. So this is an important question that can be asked in the exams, that what is aqua regia. Now come to the reaction of the non-metals with the dilute acids. Side by side I am comparing metals with non-metals. Non-metals do not react with dilute acids. Like non-metals, they do not react with water. Non-metals, they do not react with dilute acids. That is non-metal. In other words, you can say that non-metals do not displace hydrogen from dilute acids. Thank you.